4.5 billion years ago, the object you are standing on did not exist. Where Earth is now, there was a region of the solar nebula, a vast rotating cloud of gas and dust and ice and rock left over from the formation of the Sun, gradually being swept up by gravitational attraction into increasingly large bodies. The process was not gentle. It was not gradual in any sense that the word suggests patience or care. It was continuous, violent, catastrophic collision at every scale simultaneously. Boulders striking boulders, mountains striking mountains, objects the size of small planets striking each other at velocities measured in kilometers per second, releasing energies that melted everything they touched and everything around it, building a growing sphere of molten rock that accumulated mass through the same violence that prevented anything on its surface from surviving. The early Earth was not a planet with a difficult environment. It was a liquid, a sphere of magma roughly the size of the current planet, glowing red and orange across its entire surface, covered by an atmosphere of steam and carbon dioxide and hydrogen sulfide and sulfur dioxide, with surface temperatures high enough to keep rock in a liquid state. There was no ocean. Water existed only as vapor in the atmosphere, cycling between the superheated surface and the clouds in a continuous rain of boiling water that re-evaporated before it could accumulate. There was no solid ground. There was no atmosphere in any sense compatible with what that word means to a living organism. There was a ball of molten rock in space, accreting mass from a continuing bombardment of smaller objects, radiating heat into space as fast as the impacts and the decay of radioactive elements within the growing body could supply it. This was Earth. This specific object. The one you are on right now. Approximately 4.5 billion years ago, during this period of continuous bombardment, a Mars-sized body that scientists call Theia collided with the proto-Earth in one of the most catastrophic single events in the history of this solar system. The collision was not a grazing impact or a glancing blow. It was a direct strike at high velocity between two planetary-scale objects, each massive enough to have differentiated into a core and mantle and early crust. The energy released by the collision was sufficient to vaporize a significant fraction of both objects. The debris, both from the impactor and from the outer layers of the proto-Earth, was flung into orbit around the surviving body in a ring of molten rock and vapor. Over thousands of years, this debris coalesced under its own gravity into the Moon, the collision that created the object that controls Earth's tides and stabilizes Earth's axial tilt and made possible the conditions under which complex life eventually developed was, at the moment it occurred, an event that would have appeared, to any observer capable of witnessing it, like the total destruction of a planet. The Earth that emerged from this collision was not better than the one before it. It was worse, hotter, more thoroughly melted, more completely resurfaced by the energy of the greatest impact in its history. The Moon, newly formed and much closer to Earth than it is today, raised enormous tidal forces in the magma ocean, churning it, preventing the surface from cooling, adding another mechanism to the already overwhelming heat budget that kept the planet liquid. This is the world where you live, not metaphorically, not in the sense that the past is connected to the present through a chain of causation that you can choose to engage with or ignore. Literally, the atoms that constitute your body were part of this magma ocean. The iron in your blood was part of the molten core that formed during this period as heavy elements sank through the liquid planet toward its center. The calcium in your bones was part of the early crust that repeatedly melted and resolidified as the bombardment continued. Every element heavier than hydrogen and helium in your body was forged in the nuclear furnaces of stars that died before the sun formed, scattered through the galaxy by supernova explosions, gathered into the solar nebula, incorporated into the proto-Earth, processed through the hell of the planet's formation, and eventually, through a sequence of chemical and biological events spanning billions of years, arranged into the specific molecular configuration that constitutes a living human being. You are made of stardust. That phrase has been repeated so often in popular science communication that it has lost most of its impact, reduced from a staggering physical fact to a comforting metaphor. But it is not a metaphor. It is a precise description of the origin of your atomic constituents. The carbon atoms in your DNA were not produced by any process occurring on Earth. They were fused from helium nuclei in the cores of stars that burned and died billions of years before Earth formed. The oxygen atoms in the water that constitutes 60% of your body mass were produced in the same stellar furnaces. The iron, the calcium, the phosphorus, the sulfur, every element that participates in your biochemistry was synthesized in stellar interiors and distributed through the galaxy by stellar death. You are the universe looking at itself through instruments it built from its own remains. But the stardust is only the beginning of the story, because stardust is everywhere. Every rocky planet in the solar system, every asteroid, every comet, every moon orbiting every gas giant is also made of stardust. Mars is made of stardust. Venus is made of stardust. The moons of Jupiter are made of stardust. The difference between you and a rock on the surface of Mars is not the material. The material is essentially the same. The difference is what happened to the material over 4.5 billion years of planetary history on this specific planet. What happened to it here is the most astonishing sequence of events in the known universe. Approximately 4 billion years ago, something occurred on the surface of this cooling, still violent planet that has never been confirmed to have occurred anywhere else in the observable universe, despite decades of searching with increasingly powerful instruments. Chemistry became biology. Non-living molecules assembled themselves into structures capable of the one thing that distinguishes life from non-life: self-replication. A molecule, or a collection of molecules, in some warm, shallow pool or hydrothermal vent or on the surface of a mineral grain, arranged itself in a configuration that could use the chemical energy available in its environment to make copies of itself. Imperfect copies, which is crucial, because imperfect copies vary, and variation, acted on by the differential survival of better and worse configurations, is the engine of everything that followed. The exact mechanism of this first self-replication is not yet known. The origin of life is an active area of research, and genuine uncertainty remains about the specific chemistry involved. What is not uncertain is that it happened. You are the evidence. Every living organism on Earth, from the bacteria in your gut to the blue whale and the sequoia tree and the tardigrade that survives vacuum exposure, is descended from whatever that first self-replicating chemistry was. Every living thing on Earth carries in its biochemistry the molecular signatures of this common origin. The genetic code, the specific correspondence between sequences of nucleotides and sequences of amino acids that allows DNA to encode protein structure, is essentially universal across all life on Earth. The same code is used by bacteria and fungi and plants and animals and you. This universality is not a coincidence. It is evidence of common ancestry. Every living thing on this planet is your relative, distant, incomprehensibly distant in some cases, but related through an unbroken chain of reproduction stretching back 4 billion years to whatever first replicated in the primordial chemistry of an early Earth that was still cooling from its formation. That chain has never been broken. Not once. Not by the meteorite impacts that continued for hundreds of millions of years after life began. Not by the snowball Earth episodes in which glaciation extended to the equator, and the entire planetary surface was covered in ice. Not by the mass extinction events that periodically eliminated the majority of species alive at the time. Not by the asteroid impact 66 million years ago that released the energy of billions of nuclear weapons and collapsed the food web that had sustained the dinosaurs for 165 million years. Not by any of the catastrophes that punctuate the geological record with signatures of sudden mass death. Through all of it, somewhere, something survived. Something small and adaptable enough to persist through conditions that eliminated everything else, carrying forward the molecular machinery of life, passing it to the next generation, and the next, and the next, in an unbroken chain that ends, at this particular moment, with you. 4 billion years. 4 billion continuous generations. 4 billion years of reproduction and variation and selection, with the chain never breaking, the lineage never going extinct, the molecular machinery never stopping, across environmental changes so extreme they would have been instantly lethal to anything alive today. The odds of this are not calculable in any rigorous sense. We have only one example. One planet where we know the chain began and continued. We cannot compute the probability of life originating from the frequency of an event we have only observed once, but we can observe what the chain produced. Starting from self-replicating chemistry in a primordial ocean, it produced, through 4 billion years of variation and selection, organisms capable of understanding what 4 billion years means. Organisms that could reconstruct the history of the chain from the molecular signatures it left in living cells. Organisms that could look at the magma ocean their atoms passed through and understand the physics of planetary formation. Organisms that could measure the distance to stars and calculate the age of the universe and determine the composition of galaxies billions of light years away from the spectral signatures of their light. This is what happened to the stardust on this planet. This is what did not happen on Mars or Venus or the moons of Jupiter or any other location we have examined. The stardust on those planets is still stardust. On this planet, it became aware of being stardust. That distinction is the most remarkable thing the universe has produced in 13.8 billion years of physical processes operating without awareness of themselves. And it happened here, on this specific rock orbiting this specific star in an outer spiral arm of an ordinary galaxy. Through a sequence of events so improbable that the universe may have needed all of its 93 billion light-year extent and all of its 13.8 billion year history to produce it even once. If this is the kind of thinking that finds you in the quiet hours, that patient reconstruction of the extraordinary from the materials of the ordinary, then nocturnal space is exactly where you should be. Subscribe now. Turn on notifications. Because the story that begins with magma and self-replicating molecules is not finished. It escalates. It escalates through events that look, at the moment they occur, like catastrophe, and reveal themselves, only in retrospect, to have been the necessary conditions for everything that followed. The oxygen that almost destroyed all life on Earth. The asteroid that ended the dinosaurs. The ice ages that shaped the human brain. Each one a disaster. Each one a prerequisite. Each one another link in the chain that ends with an organism capable of understanding the chain it is part of. That story is where we are going. And it starts with the smallest, most unremarkable organisms that ever lived, doing something so chemically radical that it changed the composition of the entire planetary atmosphere and nearly ended the experiment of complex life before it had properly begun. Approximately 2.7 billion years ago, in the shallow coastal waters of an Earth that would be unrecognizable to any modern observer, a group of bacteria did something that no organism had ever done before. They learned to split water molecules using sunlight. Not to drink water, not to absorb water passively through a membrane. To take a molecule of H2O, use the energy of a photon of sunlight to break the bond between the hydrogen and the oxygen, use the hydrogen in the chemistry of building organic molecules, and release the oxygen as a waste product into the surrounding environment. The oxygen was garbage, a metabolic byproduct of no use to the organisms producing it, expelled into the water and from there into the atmosphere the way a factory expels exhaust. The organisms doing this, the cyanobacteria, had no awareness of what they were doing. They had no awareness of anything. They were single-celled organisms with no nucleus, no organelles, no complexity beyond the molecular machinery required to carry out their chemistry. They were not attempting to change the world. They were not pursuing a strategy. They were doing what their chemistry compelled them to do, which was absorb sunlight and build organic molecules and reproduce. And the oxygen was simply what was left over when the useful part of the reaction was complete. What the oxygen did to the world was catastrophic. The early Earth's atmosphere contained essentially no free oxygen. This is not a guess or an inference. It is directly recorded in the geological record by the behavior of iron in ancient rocks. Iron in the presence of oxygen forms iron oxide, rust, the reddish-brown mineral that colors the banded iron formations found in ancient geological strata. Before the Great Oxidation Event, as it is now called, iron dissolved freely in the oceans because there was no oxygen to react with it. Ancient seafloor sediments contain layers of reduced iron minerals that could only have been deposited in an oxygen-free environment. After the Great Oxidation Event, the sedimentary record changes. Banded iron formations show the signatures of oxidized iron. The chemistry of the ancient ocean is written in the rock for anyone who knows how to read it. The transition from an oxygen-free atmosphere to an oxygen-containing one occurred approximately 2.4 billion years ago, roughly 300 million years after cyanobacteria began their oxygen-producing chemistry. The delay reflects the time required for the oxygen output of the cyanobacteria to exceed the capacity of the environment to absorb it. The early ocean contained enormous quantities of dissolved iron and other reduced minerals that reacted with oxygen as fast as it was produced, consuming it before it could accumulate in the atmosphere. For hundreds of millions of years, the cyanobacteria produced oxygen and the ocean absorbed it, with the balance maintained at essentially zero atmospheric oxygen. The banded iron formations that miners extract today as iron ore are the chemical record of this period. Layer after layer of iron oxide, deposited on the seafloor as the oxygen produced by cyanobacteria, oxidized the dissolved iron out of the water column. Eventually, the dissolved iron was exhausted. The sink that had consumed oxygen as fast as it was produced was depleted, and oxygen began to accumulate in the atmosphere for the first time in the planet's history. For the overwhelming majority of organisms alive at the time, this was the equivalent of a planetary poison gas attack. Life had evolved over the previous 1.5 to 2 billion years in an atmosphere with essentially no oxygen. The biochemistry of every living organism on Earth at that time was calibrated to an oxygen-free world. Oxygen for these organisms was not a resource. It was a reactive, destructive chemical that combined with organic molecules in ways that broke them apart, that generated free radicals capable of damaging DNA and disrupting metabolism, that was, in every relevant biochemical sense, toxic. The Great Oxidation Event was the largest mass extinction in the history of life on Earth, larger, by most measures, than the end Cretaceous extinction that eliminated the dinosaurs, larger than any of the other mass extinctions that punctuate the geological record. The organisms that had dominated the planet for billions of years, the anaerobic bacteria and archaea that had built the first ecosystems in an oxygen-free world, were devastated. Most were driven to extinction or into refugia, where oxygen still could not reach. The sediments at the bottom of deep oceans, the interior of other organisms, the anaerobic environments that persist to this day in swamps and intestines and ocean floor sediments. The dominant biochemistry of the planet, refined over billions of years for an oxygen-free world, was destroyed by the waste product of a single group of microorganisms that had no awareness that they were doing anything at all. This is the first time in this story where the pattern that defines Earth's history becomes visible. The pattern is this: the events that look, at the moment they occur, like catastrophe, are the events that create the conditions for everything more complex and more remarkable that follows. The Great Oxidation Event was a catastrophe for the organisms that experienced it. It was a prerequisite for you. Oxygen is not merely a substance that animals happen to use for respiration. It is the most energetically efficient oxidant available in the chemistry of life. When an organism burns glucose in the presence of oxygen, the energy extracted from that reaction is approximately 18 times greater than the energy extracted from burning the same glucose in the absence of oxygen through anaerobic fermentation. 18 times. Aerobic respiration, the oxygen-dependent metabolism that every animal on Earth uses, including you, is not merely a different way of extracting energy from food. It is a categorically more powerful way. It provides the energy budget that makes complexity possible. Complex multicellular organisms require enormous amounts of energy to build and maintain. A human body contains approximately 37 trillion cells, each one a sophisticated metabolic machine running thousands of chemical reactions simultaneously, each one requiring a continuous supply of energy to maintain the concentration gradients across its membranes and to synthesize the proteins it needs, and to repair the damage that normal operation causes to its components. Fueling 37 trillion cells simultaneously at the energetic intensity required for the function of a human nervous system is only possible because aerobic respiration extracts energy from food at a rate that anaerobic metabolism cannot approach. Without oxygen, the energy budget for complex multicellular life does not close. The mathematics of energy supply and energy demand at the cellular level does not permit organisms of mammalian complexity to exist in an oxygen-free biochemical environment. The Great Oxidation Event, which destroyed most of the life that existed at the time, it was the event that made possible every complex organism that has existed since. It was the necessary catastrophe, the disaster that created the conditions for everything that followed. But oxygen alone was not sufficient to produce complex life. Even after the Great Oxidation Event, Earth spent another 1.5 billion years as a planet dominated by single-celled organisms. The bacteria and archaea that survived the oxygen catastrophe adapted to the new chemical environment, developed aerobic metabolisms, colonized the oxygen-rich shallows of the ocean, and eventually the land surface. But complexity, the organization of cells into differentiated tissues with specialized functions, the division of labor between cells that defines multicellular life, did not appear for another 1.5 billion years after the atmosphere became oxygenated. Something else was needed. That something was one of the most improbable events in the history of biology. Approximately 1.5 to 2 billion years ago, a bacterium was engulfed by a larger cell and survived. Not digested, not destroyed, survived. And not merely survived, but entered into a relationship with its host cell that eventually became so thoroughly integrated that the two could no longer exist independently. The engulfed bacterium became the mitochondrion, the organelle responsible for aerobic respiration in every complex cell on Earth. Every cell in your body, every cell in every animal and plant and fungus, contains within it the descendant of that ancient bacterium, still performing its original function, still carrying its own DNA, still dividing independently of the cell that contains it, still bearing the molecular signatures of its bacterial origin. This event, called endosymbiosis, was not evolution in the ordinary sense of gradual variation and selection. It was the merger of two previously independent lineages into a single organism, the creation of a new level of biological organization from the combination of what existed before. It gave complex cells an internal power plant, capable of running aerobic respiration at the scale required for multicellular complexity. Without the mitochondrion, the eukaryotic cell, the type of cell from which all animals and plants and fungi are built, does not exist. Without the eukaryotic cell, multicellular life does not exist. Without multicellular life, you do not exist. The mitochondrion in every cell of your body is a captured bacterium. A prisoner taken approximately 1.5 to 2 billion years ago that never escaped, that became so thoroughly integrated into the cell that captured it that neither can now survive without the other, that has been passed from cell to cell in an unbroken lineage extending from that first endosymbiotic event to the mitochondria dividing in your liver and muscle and brain cells right now. When you breathe in, the oxygen you absorb is used by these ancient bacterial descendants to power the chemistry of your existence. You are running on captured bacteria. The energy that moves your fingers and generates the electrical signals in your brain and maintains the temperature of your body comes from organelles whose ancestors were free-living, independent organisms in an ocean 1.5 billion years ago. This is Earth's history. Not a smooth progression from simple to complex. A series of accidents and catastrophes and improbable events, each one devastating in the moment, each one creating conditions that made the next step possible. The magma ocean that made the planet, the Theia impact that made the moon and stabilized the axial tilt that moderates climate, the origin of self-replication in the primordial chemistry, the cyanobacteria that poisoned the atmosphere and made aerobic respiration possible, the endosymbiosis that gave complex cells the power supply required for multicellular organization. Each step was necessary. Each step was improbable. Each step looks, when examined closely, like either a catastrophe or a miracle depending on the timescale from which it is viewed. From the timescale of the organisms experiencing it, the Great Oxidation Event was extinction. From the timescale of the billion years that followed, it was the necessary condition for every complex organism that has ever lived. From the timescale of a human lifetime, an asteroid impact is unambiguous catastrophe. From the timescale of the mammals that radiated into the ecological space vacated by the dinosaurs, it was opportunity. The catastrophe and the miracle are the same event, separated only by the timescale from which they are observed. And the timescale that reveals the miracle is always longer than the timescale that reveals the catastrophe. This is perhaps the most important lesson that Earth's history teaches. The events that shape what comes next are not legible as anything other than disaster in the moment they occur. The pattern only becomes visible from a distance, from the vantage point of what actually followed. What followed the oxygen catastrophe was, eventually, animals. What followed the endosymbiosis was, eventually, complex multicellular life. What followed both was 600 million years of escalating complexity that produced nervous systems and eyes and limbs and language and the capacity to sit somewhere on a planet that was once a magma ocean and reconstruct, from the molecular signatures in living cells and the chemical records in ancient rocks and the light from distant stars, the 4.5 billion year history of the specific sequence of accidents and catastrophes that produced the moment you are in right now. That reconstruction is what nocturnal space exists to pursue, not the comfortable version that skips the catastrophes and presents only the wonder at the end. The complete version that follows every step of the chain, including the ones that look like disasters, including the ones that were disasters, through to the place they eventually lead. The place they led is here, and the next step in the story is the one that almost ended the experiment permanently, not once but repeatedly, in events so extreme that the entire surface of the planet was covered in ice, and the oceans nearly froze solid and life clung to existence in whatever small warm refugia the physics of the frozen planet permitted. The snowball Earth episodes. The periods when catastrophe was not the great oxidation of the atmosphere or a single asteroid impact, but a planetary deep freeze lasting tens of millions of years. And what survived them, and what that survival made possible, is the next chapter of the most astonishing story the universe has produced in 13.8 billion years of physical processes operating without a narrator. There is a moment in the history of this planet that geologists call the most extreme climate event in Earth's known history. Not the asteroid impact that killed the dinosaurs, not the volcanic eruptions that triggered the end Permian extinction, the largest mass extinction in the fossil record, which eliminated roughly 96% of marine species and 70% of terrestrial vertebrate species in what paleontologists sometimes call the Great Dying. Not the great oxidation event that poisoned the atmosphere and drove most of the life alive at the time to extinction. The most extreme climate event in Earth's history was a period, or more precisely a series of periods, between approximately 720 and 635 million years ago when the planet froze. Not partially, not at the poles and in the high latitudes while the tropics remained warm, entirely. From pole to pole across every ocean and every continent, from the equator to the poles, the surface of Earth was covered in ice. Geologists call this snowball Earth. The name is deceptively gentle for what it describes, a planet with surface temperatures averaging somewhere around -50 degrees Celsius. Oceans frozen to depths estimated at hundreds of meters in some regions. The ice surface reflecting roughly 60 to 70% of incoming sunlight back into space rather than absorbing it, creating a feedback loop in which the cold makes more ice, which reflects more sunlight, which makes more cold, which makes more ice. A runaway cooling event that, once initiated, had no obvious mechanism for reversal. A planetary deep freeze that lasted not years or decades, but tens of millions of years. An epoch of cold so complete and so prolonged that the very existence of any surviving life is, from the perspective of thermodynamics and ecology, remarkable enough to require explanation. The evidence for snowball Earth episodes is embedded in the geological record in multiple independent lines of evidence that converge on the same conclusion from different directions. Glacial deposits, the characteristic sedimentary signatures of ice sheets grinding across rock surfaces and depositing their debris, are found in rocks from this period at every latitude, including paleomagnetically confirmed equatorial latitudes. In a normal glaciation, the glacial deposits appear at high latitudes and are absent at low latitudes because the tropics remain warm. In the snowball Earth episodes, glacial signatures appear everywhere, including in rocks that were demonstrably located near the equator when they were deposited. The ice reached the tropics. The ice covered everything. Additionally, immediately above the glacial deposits in the geological record, there are thick layers of carbonate rock, limestone and dolomite, deposited in shallow marine environments. These cap carbonates, as they are called, represent a dramatic chemical event in the oceans immediately following the glaciation. The specific chemistry of the carbonates, their isotopic signatures, the speed with which they were deposited, all record a rapid and extreme shift in ocean chemistry that is consistent with the buildup of carbon dioxide in the atmosphere during the glaciation and its sudden release into the ocean atmosphere system as the ice melted. The cap carbonates are the chemical fingerprint of the end of each snowball Earth episode, written in limestone on every continent. How did the planet freeze so completely? The mechanism involves the same ice albedo feedback that makes climate systems sensitive to perturbations in ways that can produce nonlinear responses. At some point in the late Proterozoic, a combination of factors that is still debated among geologists, possibly including the weathering of large volcanic provinces that drew down atmospheric carbon dioxide, possibly including the configuration of continents at low latitudes where ice formation is more effective at triggering the feedback, shifted the climate system past a tipping point. Ice expanded from the poles toward the equator. As it expanded, it reflected more sunlight, cooling the planet further, causing more ice to form. The feedback accelerated. Before it could be stopped by any natural counterprocess operating on the relevant timescale, the ice had reached the equator, and the planet was locked in a self-reinforcing frozen state. How did the planet thaw? This is the part that reveals something fundamental about the relationship between catastrophe and rescue in Earth's history. It was rescued by another catastrophe, the one geological process that continued operating throughout the entire snowball Earth episodes. Indifferent to the ice covering the surface was volcanic activity. Volcanoes emit carbon dioxide. They did so before the freeze. They continued doing so during the freeze. But during the freeze, the normal mechanism that removes carbon dioxide from the atmosphere, the weathering of silicate rocks by carbonic acid formed when CO2 dissolves in rainwater, was almost entirely shut down because the surface was covered in ice. Rain could not reach rock. The weathering process halted. Carbon dioxide emitted by volcanoes accumulated in the atmosphere with no removal mechanism to balance it. Over tens of millions of years, volcanic carbon dioxide built up in the atmosphere to concentrations hundreds of times higher than anything in Earth's current or recent geological history. Eventually, the concentration of this greenhouse gas reached a threshold where its warming effect overcame the cooling effect of the reflective ice surface. The planet began to warm. As it warmed, ice began to melt. As ice melted, the surface albedo decreased, absorbing more sunlight, warming faster. The runaway cooling feedback reversed into a runaway warming feedback. The deglaciation, when it came, was extremely rapid in geological terms. Perhaps thousands of years, temperatures swung from deep freeze to conditions warmer than anything on Earth today in a geological eye blink. The cap carbonates record this rapid chemical transition in the ocean atmosphere system as the massive CO2 pulse was absorbed by the newly liquid ocean. Life survived. This statement requires emphasis proportional to what it represents. The snowball Earth episodes lasted tens of millions of years. For most of that duration, photosynthesis in the open ocean was essentially impossible because the ocean's surface was frozen and the ice covered with snow that reflected away the sunlight that photosynthetic organisms require. The food chains that depended on photosynthesis were severed. The ecological systems that had developed over the preceding billions of years were devastated. The organisms that managed to persist through tens of millions of years of planetary freeze were confined to refugia. Whatever small, warm, or liquid environments remained accessible, possibly hydrothermal vents in the deep ocean where volcanic heat kept water liquid, possibly thin meltwater pools on the ice surface where liquid water could briefly exist. possibly cracks in the ice where enough sunlight penetrated to support minimal photosynthetic activity. The organisms that survived were not the dominant forms of the pre-glacial world. They were the survivors, the ones whose specific biochemical tolerances, whose specific habitat preferences, whose specific metabolic capabilities happened to be compatible with the most extreme cold the planet had ever experienced. Selection pressure during a snowball Earth episode was the most intense selection pressure in the history of life on this planet. The organisms that came out the other side were those whose biology had been tested against conditions that eliminated everything less robust. And this is where nocturnal space pauses, because what comes immediately after the snowball Earth episodes in the fossil record is one of the most dramatic and most discussed events in the entire history of life on this planet. Something happened in the geological blink of time following the deglaciation that geologists and biologists have been trying to explain for over a century. If you have been with this channel long enough to know how these stories unfold, you already sense that the catastrophe and the wonder are about to converge in a way that changes the picture completely. Subscribe to Nocturnal Space now if you have not already. Turn on notifications, because what the ice almost destroyed was also what the ice, through the selection pressure it imposed and the ecological opportunity created by the deglaciation, ultimately made possible. The timing is not coincidence. The pattern holds. Within roughly 30 to 40 million years of the final snowball Earth episode ending, the fossil record documents the Cambrian explosion, the rapid appearance in the geological record, over a period of approximately 20 million years, of representatives of most of the major animal body plans that exist today. Before the Cambrian explosion, the fossil record shows mostly simple organisms, colonial microbial mats, the strange, flat-bodied Ediacaran organisms whose relationships to modern life remain debated, simple sponges. After the Cambrian explosion, the fossil record shows trilobites and brachiopods and early chordates and predators with eyes and prey with shells and the full ecological complexity of a functioning marine ecosystem with multiple trophic levels and the evolutionary arms race between predator and prey that drives the development of increasingly sophisticated sensory and locomotor and defensive capabilities. The Cambrian explosion is not fully understood. The specific combination of factors that triggered it is still debated, but several of the factors that are clearly relevant connect directly to the snowball Earth episodes that preceded it. The deglaciation produced an enormous pulse of nutrients. Minerals weathered from newly exposed rock and deposited into the ocean, fueling a bloom of productivity in the newly ice-free ocean. The extreme selection pressure of the glaciation may have driven the evolution of genetic regulatory systems capable of producing more diverse body plans. The ecological vacuum left by the devastation of the pre-glacial biosphere created opportunity for organisms with novel body plans to diversify without competition from established ecological dominance. The catastrophe created the conditions for the explosion. And the Cambrian explosion matters to this story in the most direct possible way. Because the Cambrian fauna included the first chordates, primitive, small, soft-bodied organisms with a notochord, the stiffening rod that in their descendants would become a vertebral column, the first members of the lineage that eventually produced fish and amphibians and reptiles and mammals and, at the end of a chain of transformations spanning 500 million years, you. The lineage that contains everything with a backbone, everything with a skull, everything with a nervous system centralized enough to produce the kind of complex behavior that eventually gave rise to intelligence, traces its ancestry to the Cambrian organisms that radiated into the ecological opportunity created by the end of the snowball Earth. Without the ice, the Cambrian explosion may not have occurred when it did, or in the form it did. Without the Cambrian explosion, the chordate lineage does not appear in the fossil record at the time it does. Without the chordate lineage, vertebrates do not exist. Without vertebrates, fish do not colonize the land. Without fish colonizing the land, tetrapods do not exist. Without tetrapods, mammals do not exist. Without mammals, primates do not exist. Without primates, humans do not exist. Without humans, there is no one to reconstruct this chain of events from the fossil record and the rock chemistry and the paleomagnetic signatures in ancient glacial deposits, and to understand with precise scientific clarity what the ice almost destroyed and what it ultimately made possible. The snowball Earth almost won. The ice covered the planet for tens of millions of years. Life clung to existence in the most marginal of refugia. The organisms that survived were a devastated remnant of what had existed before. And then the ice lost. Slowly, at first, then catastrophically fast, and as the volcanic carbon dioxide that had been building in the atmosphere for tens of millions of years finally overwhelmed the reflective power of the ice surface, and the feedback reversed, and the planet thawed. And what survived the thaw, shaped by the most intense selection pressure in the history of life and released into an ocean suddenly rich with nutrients and empty of competitors, gave rise to the explosion of animal life that put a backbone into the history of this planet and set in motion the 500 million year sequence of evolutionary events that produced the organism reading these words. The ice almost won. The ice losing is why you exist. That is the pattern. The catastrophe and the miracle are the same event. The timescale determines which one you see. And the next catastrophe in this story is the one most people know by name. The one with the asteroid and the dinosaurs and the 66 million years of geological record leading up to the moment, 37 trillion cells organized into a self-aware configuration started asking questions about the ice that almost ended everything. That story is the next place we go. And it follows the same pattern. The disaster is total. The survival is barely. The aftermath is everything. 66 million years ago, on an ordinary day that was indistinguishable from any of the hundreds of millions of ordinary days that had preceded it, a rock approximately 10 to 15 kilometers in diameter, traveling at roughly 20 kilometers per second, entered Earth's atmosphere, above what is now the Yucatan Peninsula of Mexico. The entry itself lasted seconds. The object was too large and too fast for the atmosphere to do anything meaningful to it. The atmosphere that had burned the Chelyabinsk asteroid into fragments at an altitude of 30 kilometers, that had reduced the Tunguska object to an airburst before it could reach the ground, had no mechanism capable of significantly slowing or fragmenting an object of this mass at this velocity. The atmosphere was simply what the asteroid passed through on its way to the ground. The impact released energy equivalent to approximately 10 billion nuclear weapons detonated simultaneously at a single point. The crater it produced, now called the Chicxulub crater, is approximately 180 kilometers in diameter and extends beneath the Gulf of Mexico. The immediate effects of the impact were local in the geographic sense and total in the destructive sense. Everything within hundreds of kilometers was incinerated in seconds. The shockwave that propagated through the crust triggered massive earthquakes across the entire planet within minutes. The ejecta thrown into the atmosphere by the impact, superheated rock and vapor launched on ballistic trajectories that carried it across the planet before it re-entered the atmosphere and heated through friction, produced a global pulse of infrared radiation intense enough to ignite surface fires across every continent. Every forest on every landmass on Earth was simultaneously set on fire within approximately an hour of the impact, not by the impact itself, but by the re-entering ejecta, heating the atmosphere to temperatures exceeding the ignition point of wood and dried vegetation. What followed the immediate destruction was in many ways more comprehensively lethal than the impact itself. The dust and ash and soot from the global firestorm, combined with the sulfate aerosols produced by the vaporization of the sulfur-rich carbonate rocks at the impact site, rose into the stratosphere and spread globally within weeks. This aerosol layer blocked sunlight from reaching the surface with extraordinary efficiency. Photosynthesis, which powers the base of essentially every food chain on Earth through the conversion of sunlight and carbon dioxide into organic matter, collapsed globally. Plant life, from the largest forests to the smallest aquatic phytoplankton, could not photosynthesize without sunlight. The food chains that depended on plant productivity collapsed from the bottom up. Herbivores starved when the plants disappeared. Carnivores starved when the herbivores disappeared. The darkness lasted months to years, during which surface temperatures dropped catastrophically as the aerosol layer prevented solar heating of the surface. The result was the fifth mass extinction in Earth's history, the end Cretaceous extinction, which eliminated approximately 76% of all species on Earth. Among the victims were the non-avian dinosaurs, the dominant large-bodied terrestrial vertebrates, for the preceding 165 million years. from Tyrannosaurus rex and Triceratops and Brachiosaurus, and every other member of the extraordinary diversity of large dinosaur species that had evolved across 165 million years of evolutionary diversification, nothing survived except the small feathered theropod lineage that we now call birds. The dinosaurs had ruled terrestrial ecosystems since the Triassic. They were eliminated in what is, geologically speaking, an instant. This is what most people know about the Chicxulub impact. The asteroid came, the dinosaurs died, the world changed. The narrative usually stops there, with the extinction as the conclusion, the disaster as the final word. But the extinction was not the conclusion. It was the beginning. And what it was the beginning of is the reason you are capable of reading this sentence. The dinosaurs did not merely go extinct. They vacated. They had occupied, for 165 million years, every significant ecological role available to large-bodied terrestrial vertebrates. The apex predator roles, the large herbivore roles, the mid-size omnivore roles, the roles requiring bipedal locomotion, and those requiring quadrupedal locomotion, and those exploiting the high-browse niche of tall vegetation. Every ecological role that a large-bodied land animal could occupy had been occupied by a dinosaur, refined by 165 million years of evolutionary optimization and defended against displacement by the competitive advantages that 165 million years of specialization provides. There was no space in the terrestrial ecosystems of the late Cretaceous for a mammal to diversify into large-body ecological roles, because those roles were filled by animals far better adapted to occupy them than any mammal then existing. The mammals of the late Cretaceous were small, not small in the way that mice are small relative to larger mammals, small in the way that no mammal of the late Cretaceous significantly exceeded the size of a modern house cat, and most were substantially smaller. They occupied the ecological margins, the niches that required small size and nocturnal habits and generalist diets that the large, visually oriented, specialized dinosaurs had not bothered to compete for. Insect eating, seed eating, burrowing, the ecological roles that were compatible with being small and warm-blooded and able to retreat into burrows or dense vegetation to avoid the sensory capabilities of larger predators. These ecological constraints had shaped mammalian evolution for over 100 million years. Mammals had existed since the Triassic. They had persisted through 165 million years of dinosaur dominance without ever breaking out of the ecological margins that the dinosaurs left available. Not because mammals were evolutionarily incapable of larger size or greater diversity, because the ecological space for that diversity was occupied. Because every time a mammal lineage began to diversify toward a larger body ecological role, it was competing against 165 million years of dinosaurian evolutionary refinement and losing. The asteroid removed the competition in 24 hours. The ecological space vacated by the extinction of the non-avian dinosaurs was not merely large, it was enormous. Every large-body terrestrial vertebrate ecological role on every continent on Earth opened simultaneously. The apex predator niches, the large herbivore niches, the semi-aquatic niches, the plains grazing niches, the forest browsing niches. Every ecological role that had been occupied by a dinosaur was now available. And the mammals that had survived the extinction, small, generalist, adaptable, warm-blooded, capable of maintaining activity across a wider range of temperatures than the ectothermic reptiles they now found themselves sharing a devastated planet with, were positioned to exploit it. The radiation that followed is one of the most dramatic in the fossil record. In the approximately 10 million years following the Chicxulub impact, mammals diversified from a handful of small, ecologically marginal groups into the full range of body sizes and ecological roles that characterize modern mammalian diversity. The Paleocene and Eocene fossil record shows this radiation in extraordinary detail. Large herbivores appear within a few million years of the extinction. Carnivores capable of hunting them appear shortly after. Aquatic mammals appear. Arboreal mammals appear. The ecological vacuum was filled with a speed that is extraordinary in geological terms, driven by the release of evolutionary potential that had been suppressed for 165 million years by the competitive dominance of the dinosaurs. Among the mammals that diversified into the newly available ecological space were the primates. The first primates appear in the fossil record shortly after the Chicxulub extinction, small arboreal mammals that exploited the forest environments of the early Paleocene. They were not remarkable among the mammals of their time. Small, visually oriented, adapted for life in the trees, with the forward-facing eyes and grasping hands that would eventually become the defining characteristics of the primate order. They were one lineage among many, radiating into the ecological opportunity created by the extinction. But the primate lineage had something that distinguished it from other mammalian lineages in ways that only become apparent in retrospect, from the vantage point of what it eventually produced. The arboreal lifestyle that primates specialized in placed a premium on visual processing, on the three-dimensional spatial reasoning required to move through a complex three-dimensional environment, on the fine motor control required to grasp branches and manipulate objects, on the social complexity that living in groups requires. These selective pressures, maintained across tens of millions of years of primate evolution, expanded the brain relative to body size in the primate lineage faster and further than in any other mammalian order. The neural investment required for the visual and motor and social capabilities of arboreal primates produced, as a byproduct of its primary functions, the cognitive architecture that eventually made possible the kind of abstract reasoning that distinguishes human intelligence. The human brain did not evolve for abstract reasoning. It evolved for arboreal locomotion and social navigation and tool use, and the specific cognitive demands of the ecological niche that primates occupied in the forests of the post-dinosaur world. Abstract reasoning, language, mathematics, science, philosophy, the capacity to reconstruct the history of the universe from fossil records and rock chemistry and starlight, are what you get when the neural machinery required for primate ecology is elaborated over tens of millions of years and eventually reaches a threshold of complexity that produces capabilities far beyond anything the original selective pressures required. You are the unintended consequence of an asteroid impact. The cognitive capacity that allows you to understand the history of life on Earth, including the history of the asteroid impact that made your existence possible, is the product of 66 million years of mammalian evolution in the ecological space vacated by the dinosaurs, which is the product of the most catastrophic single day in the history of terrestrial life on this planet, which was an event of pure destruction with no awareness of what it would eventually make possible. The asteroid did not come to clear the way for mammals. It came because orbital mechanics put it on a collision course with Earth, and the atmosphere was insufficient to stop it. The dinosaurs did not die to make room for us. They died because the environmental consequences of the impact were incompatible with the ecological requirements of large-bodied ectothermic vertebrates in ways that the small, warm-blooded generalist mammals survived by the narrowest of margins. The mammalian radiation that followed was not directed toward producing intelligence. It was driven by ecological opportunity and the same variation and selection that has driven every evolutionary transition in the history of life on Earth. And yet, here we are, the unintended consequence of all of it. The organism that evolved the capacity to understand the chain of events that produced it. From the magma ocean to the oxygen catastrophe to the snowball Earth to the asteroid that cleared the way for the mammalian radiation that eventually produced the primate lineage, that eventually produced a species that can reconstruct all of it from the evidence the universe left behind. The asteroid did not save us in any intentional sense. It simply eliminated the competition and left the ecological space open. That the space was filled by a lineage that eventually produced awareness is not something the asteroid accomplished. It is something that 66 million years of evolution accomplished in the ecological opportunity that the asteroid created, following the pattern that has defined Earth's history from the beginning. Catastrophe creates conditions. The conditions are exploited by what survives. What survives is shaped by the catastrophe into something that would not have existed without it. The chain continues. And the next link in it is the one that produced the specific thing that makes human intelligence different from the intelligence of every other primate that the mammalian radiation produced. the thing that allows the information in one mind to be transmitted to another mind with sufficient fidelity that knowledge accumulates across generations rather than dying with each individual who acquires it. The thing that turned a sophisticated primate brain into the foundation of a civilization capable of understanding its own history. That thing is the subject of the next segment, and it is, in its own way, as improbable and as consequential as every catastrophe that preceded it. Approximately 300,000 years ago, in the landscapes of what is now Africa, a primate existed that was anatomically indistinguishable from a modern human being. The same skull shape, the same brain volume, approximately 1,300 to 1,400 cubic centimeters, the same as yours. The same vocal tract anatomy capable of producing the full range of sounds that human language requires. The same hands with the same precision grip that allows the manipulation of tools, with the fine motor control that distinguishes human tool use from the tool use of other primates. Anatomically, physiologically, neurologically, this organism was you. Its brain was your brain. Its body was your body. Its capacity for language and abstract reasoning and social complexity, as measured by the physical structures that support those capacities, was your capacity. And for approximately 200,000 years, it did relatively little with any of it. The archaeological record of early Homo sapiens, the 200,000 years between the anatomical appearance of our species and what archaeologists call the behavioral revolution, is not empty. These were not unintelligent or incapable organisms. They made tools. They used fire. They buried their dead with what appears to be intentional arrangements suggesting some form of symbolic or spiritual thought. They ranged across Africa and into other continents. They were, by any reasonable assessment, sophisticated animals, but the tools they made changed very slowly. Across thousands of years, the same tool designs persisted with minimal innovation. The same flaking techniques, the same core reduction strategies, and the same functional forms appearing site after site across vast geographic ranges with little variation. The knowledge embedded in tool manufacture was transmitted from generation to generation, but it accumulated slowly. A craftsperson living 150,000 years ago made essentially the same tools as a craftsperson living 100,000 years ago. The 50,000 years between them produced less technological change than the last 50 years of human history produced in any randomly selected technological domain. Something changed approximately 50,000 to 70,000 years ago. Archaeologists call it the Upper Paleolithic Revolution, or the Behavioral Modernity Transition, or various other names that all point at the same observation in the archaeological record. The pace of change accelerated. Cave paintings appeared. Jewelry appeared. Long-distance trade networks appeared, evidenced by raw materials found far from their geological sources. Harpoons and needles and composite tools with multiple components appeared. The diversity of tool forms increased dramatically. Regional variation in tool traditions appeared, suggesting that different human groups were developing distinct cultural traditions rather than sharing a single, slowly evolving technological repertoire. The archaeological record shifts from the slow, nearly static technological progression of the preceding 200,000 years to something that looks, in geological time, like explosive diversification. What changed is debated. The anatomy had not changed. The brain volume had not changed. The vocal tract had not changed. Whatever happened was not a biological event in the sense of a genetic mutation producing a new physical capability. The hardware was already there. Something changed in how the hardware was being used. And the leading candidate for what changed, the explanation that best accounts for the specific pattern of change visible in the archaeological record and in the cognitive capabilities that distinguish modern human behavior from the behavior of every other animal, including our closest primate relatives, is language. Not the capacity for language. That capacity, as noted, was already present in the anatomy 300,000 years ago. What appears to have emerged or to have reached a threshold of sophistication sufficient to produce qualitative behavioral change was language of sufficient complexity and precision to transmit not just immediate information but abstract concepts. Not just here is food or danger is approaching, but the kind of embedded, recursive, hierarchically structured communication that allows one mind to transmit to another mind a model of a situation that the receiving mind has never experienced and could not have constructed independently. The kind of language that allows you to understand what happened 66 million years ago during the Chicxulub impact without having been there. The kind of language that turns individual intelligence into collective intelligence by allowing the knowledge acquired by one mind to become the knowledge of all minds connected to it through communication. This is the thing that changed everything. Not language as a communication system. Every social animal has communication systems. Bees communicate the location of food sources through dance. Vervet monkeys have distinct alarm calls for different predators. Chimpanzees communicate through gesture and vocalization with a sophistication that continues to surprise researchers. Communication is not unique to humans. What appears to be unique to humans is the specific capacity to use language to transmit complex abstract models of reality with sufficient fidelity that the receiving mind can build on the transmitted model rather than having to reconstruct it from scratch. The consequence of this capacity is cumulative culture. The accumulation of knowledge and technique across generations at a rate faster than any individual lifetime of learning could produce. When a human learns a skill, they do not start from first principles. They inherit the accumulated refinements of everyone who practiced that skill before them, transmitted through language in the form of instruction and demonstration and recorded knowledge. A modern blacksmith does not rediscover metallurgy. A modern physician does not rediscover anatomy. A modern physicist does not rediscover the laws of motion. Each of them begins their learning at the point where the last generation's learning ended, adding their own refinements to a cumulative structure that extends back through generations of practitioners. No other animal does this. Chimpanzees teach their offspring to crack nuts with stones. The technique is transmitted from mother to offspring through observation and practice. But the technique transmitted is essentially the same technique the mother learned from her mother. There is no evidence of cumulative improvement across chimpanzee generations. No progressive refinement of nut-cracking technique across decades or centuries, as each generation adds its innovations to what it inherited. The knowledge resets with each generation rather than accumulating. Individual learning is impressive. Cumulative learning across generations is uniquely human. The difference this makes to the pace of knowledge accumulation is exponential rather than linear. An individual human learning from scratch in a single lifetime can acquire a certain amount of knowledge and develop a certain level of skill in any given domain. A human learning from the accumulated knowledge of all previous humans who worked in that domain begins not at zero, but at wherever the previous generation left off. Each generation adds an increment to the cumulative total. The total grows. The next generation starts from a higher base. Their increment, added to a larger starting point, produces a larger total. The generation after that starts from an even higher base. Across thousands of generations, this process produces knowledge structures of extraordinary complexity from starting points of almost complete ignorance. This is the mechanism that produced the understanding of Earth's history described in this video. The chain from the first human who noticed that different rocks had different properties, to the first human who discovered that certain rocks could be shaped by striking them with other rocks, to the first human who discovered that certain rocks melted in fire and could be cast into new shapes, to the accumulated metallurgical knowledge of ancient civilizations, to the chemistry that emerged from that metallurgical tradition, to the atomic theory that emerged from chemistry, to the quantum mechanics that emerged from atomic theory, to the understanding of nuclear physics that allows us to calculate how stars produce elements, to the geochemistry that allows us to read the oxygen content of ancient atmospheres from the iron chemistry of ancient rocks, is a chain of cumulative knowledge transmission across hundreds of generations of human beings, each of whom added their own increment to what they inherited. No single human being understood all of it. No single human being could understand all of it within a single lifetime of learning. The knowledge distributed across the scientific community that has reconstructed the history of life on Earth is knowledge that no individual possesses and that no individual could possess. It exists only in the distributed, collectively maintained, continuously updated body of human understanding That is possible because language allows knowledge to be transmitted between minds with sufficient fidelity for cumulative improvement to occur. If this is where the story has brought you, to the recognition that the most remarkable thing about the species you belong to is not its individual intelligence but its collective intelligence. So, the intelligence that emerges from the cumulative transmission of knowledge across generations through language, then you are in the right place to understand what nocturnal space is for. This channel exists in the tradition of that cumulative transmission. Every video here draws on the accumulated knowledge of thousands of scientists and scholars and thinkers who came before and adds one more accessible layer to the structure they built. Subscribe now. Turn on notifications. Because the chain of transmission that began with whatever linguistic threshold was crossed 50,000 to 70,000 years ago in the landscapes of Africa runs through every scientific discovery and every piece of recorded knowledge and every educational resource ever created by a human being, including whatever you are watching this on. You are a node in that chain. The knowledge that reaches you here reaches you because every link in the chain going back thousands of generations held. The behavioral revolution that followed the emergence of complex language was not immediate in the archaeological record. It took time for the new capability to express itself in material culture. But once expressed, its trajectory was unmistakable. Humans spread across the entire planet within tens of thousands of years of the behavioral revolution, occupying ecological niches and geographic ranges that no other single primate species had ever colonized. They reached Australia, crossing open ocean at a time when no other land animal was capable of intentional ocean navigation. They colonized the Arctic, surviving in conditions that required the accumulated technological knowledge of fire management and insulated clothing and food preservation that could only have been developed through cumulative cultural transmission across generations. They reached the Americas, crossing or skirting the northern ice sheets at the height of the last glacial maximum in conditions that challenged the physiological limits of an African primate that had never evolutionarily encountered such cold. The global colonization of Homo sapiens, completed within approximately 50,000 years of the behavioral revolution, was made possible by cumulative culture. The technology required to survive in Siberian winters, Australian deserts, tropical rainforests, and Arctic tundra simultaneously is not technology that any individual could develop in a single lifetime of learning and experimentation. It is technology that accumulated across generations of people living in each environment, each generation inheriting the knowledge of the previous generation and adding to it, building a survival toolkit specific to each ecological context that no individual intelligence could have constructed from scratch. And then, approximately 12,000 years ago, the pace accelerated again. The Neolithic Revolution, agriculture, the deliberate cultivation of plants, and the domestication of animals as managed food sources rather than wild resources to be hunted and gathered. This transition, which occurred independently in multiple locations across the world within a few thousand years of each other, was made possible by cumulative knowledge of plant biology and animal behavior, accumulated across generations of observation by people who were not yet farmers, but who understood enough about the plants and animals around them to recognize the possibility of intentional management. Agriculture made permanent settlements possible. Permanent settlements made the accumulation of physical infrastructure possible. Physical infrastructure made the division of labor possible, which made it possible for some members of a community to specialize in knowledge production rather than food production. Specialists in knowledge production, freed from the necessity of feeding themselves, could dedicate their lifetimes to pushing the frontier of human understanding forward. The cumulative knowledge transmission that language had made possible, accelerated by writing into a form that could span not just generations of oral tradition but millennia of recorded text, produced the scientific revolution and the industrial revolution and the digital revolution and every other revolution in human capability that has occurred in the 12,000 years since the first farmer planted the first deliberate crop. Everything that makes the modern world recognizable as the modern world, every technology and every institution and every body of knowledge that distinguishes human civilization from the ecological circumstances of 70,000 years ago is the product of cumulative cultural transmission, the product of the thing that changed everything. The thing that turned individual primate intelligence into the collective intelligence of a civilization capable of looking at the rocks laid down during the Great Oxidation Event and understanding that the iron chemistry they contain records the transformation of the entire planetary atmosphere by single-celled organisms 2.4 billion years ago. You understand this because someone understood a piece of it and transmitted that piece to someone who understood a piece of it and transmitted it onward across a chain of transmission so long that its beginning is lost in the archaeological record of the behavioral revolution, and its current state is this video, reaching you through a technology that is itself the product of cumulative knowledge transmission across hundreds of generations of scientists and engineers. The chain holds. It has held for 70,000 years, and what it has produced at this particular moment in its history is the first species in the history of this planet capable of understanding the history of this planet. That understanding is where this story is heading, and the next segment is the one that puts the entire chain from the magma ocean to this moment in its cosmic context, the context that reveals why the most remarkable thing the universe has produced in 13.8 billion years of physical processes is not a star or a galaxy or a black hole. It is the thing happening in your skull right now. There is an object that fits inside a human skull. It weighs approximately 1.4 kilograms. It has the consistency of firm gelatin and the color of pale gray matter streaked with white. It consumes roughly 20% of the body's total energy budget despite comprising only 2% of body mass, running continuously at the metabolic equivalent of a dim light bulb, never fully shutting down, maintaining activity even during the deepest sleep states. It requires a continuous supply of oxygenated blood to function, becoming impaired within seconds of blood flow interruption and irreversibly damaged within minutes. It is, by the standards of any engineering specification applied to other biological organs, an extraordinarily expensive and fragile piece of biological machinery. It is also the most complex object in the known universe. That statement is not poetry or hyperbole. It is the current scientific assessment of the situation, stated with appropriate epistemic humility about what remains unknown, but with full recognition of what the available evidence indicates. The observable universe contains approximately 2 trillion galaxies. Each galaxy contains between tens of billions and hundreds of billions of stars. The Milky Way alone contains somewhere between 200 and 400 billion stars. Every one of those stars is a nuclear furnace converting hydrogen into helium at temperatures of millions of degrees, sustained by the gravitational compression of millions or billions of times the mass of this planet. Many of those stars have planetary systems. Some of those planets almost certainly have chemistry of considerable complexity, and yet nothing identified anywhere in the observable universe by any instrument humanity has ever pointed at the sky matches the structural and functional complexity of the object you are currently using to read this sentence. The human brain contains approximately 86 billion neurons. The number is large enough to require anchoring against something concrete to feel its scale. The Milky Way galaxy contains somewhere between 200 and 400 billion stars. The number of neurons in a human brain is roughly 1/5 to 1/2 the number of stars in the galaxy. Inside your skull, there are almost as many individual processing units as there are stars visible in the night sky from every location on Earth combined, counting the stars too dim to see individually, counting the stars in the densest regions of the galactic core, counting every stellar object in the entire galactic disk and halo, almost as many. But neurons are not the relevant unit of complexity. The relevant unit is the connection. Each neuron connects to other neurons through structures called synapses, chemical junctions across which electrical signals are transmitted from one cell to another. The number of synaptic connections in a human brain is estimated at approximately 100 trillion. 100 trillion. Written numerically, 100 trillion. 14 digits. The number of connections in a single human brain exceeds the number of stars in the observable universe by a factor of roughly 500. The observable universe contains an estimated 200 sextillion stars, a number so large it defeats ordinary intuition. The number of synaptic connections in a human brain exceeds it by 2 orders of magnitude. These connections are not static. They are not wires with fixed properties. They are dynamic junctions whose strength changes continuously as a function of the pattern of activity flowing through the neural circuits they constitute. A synapse that is repeatedly activated strengthens. A synapse that is rarely activated weakens. The pattern of strengths across 100 trillion connections is the physical substrate of everything you know, everything you remember, every skill you have acquired, every preference you have developed, every concept you can manipulate, every relationship you have formed. Your mind, in the most precise physical sense, is a pattern of synaptic strengths distributed across 100 trillion connections. A pattern that has been continuously modified by every experience you have ever had. From the moment your nervous system began processing sensory information in the womb to this exact moment of reading, the number of possible patterns across 100 trillion binary connections, each of which can be strong or weak, is 2 to the power of 100 trillion. This number is so large that it has no meaningful comparison. It vastly exceeds the number of atoms in the observable universe. It vastly exceeds any physically realizable quantity. The space of possible minds, defined as the space of possible synaptic strength patterns across a human neural network, is effectively infinite relative to any physical quantity the universe contains. What this means in practice is that no two human brains are identical, not even the brains of identical twins, who begin with the same genetic blueprint but whose neural connectivity is shaped from the earliest stages of development by the specific pattern of activity flowing through each developing nervous system, which depends on the specific sensory experiences each organism has, which are never perfectly identical even in organisms raised in the same household. Every human brain is unique. Every human mind is unique. The space of possible human minds is so vast that the approximately 108 billion human beings who have ever lived have collectively explored only a vanishingly small fraction of it. The complexity of the brain is not merely structural, it is dynamic. The 86 billion neurons and 100 trillion synapses are organized into circuits that process information in parallel across multiple spatial and temporal scales simultaneously. Sensory information from the environment is processed through hierarchical circuits that extract features of increasing abstraction, from the detection of contrast edges and orientation in primary visual cortex to the recognition of faces and objects and scenes in higher visual areas. Motor commands are organized through circuits that translate abstract movement intentions into the specific patterns of muscle activation required to execute them. Emotional states are processed through limbic circuits that assign motivational significance to stimuli and experiences. Memories are formed and retrieved through hippocampal neocortical interactions that consolidate experience into the long-term synaptic modifications that constitute stored knowledge. All of this happens simultaneously, continuously, without any central coordinator directing traffic between the specialized circuits, without any homunculus sitting in the frontal lobe deciding what the rest of the brain should be doing. The mind that results from this distributed, parallel, self-organizing neural activity is not produced by any single component or any single process. It emerges from the interaction of all components and all processes, in the way that the behavior of a market emerges from the interactions of individual buyers and sellers without any single participant controlling the outcome. The specific capability that makes human minds uniquely remarkable among biological brains is not any single processing capacity. Human eyes have worse visual acuity than many birds. Human hearing spans a narrower frequency range than many mammals. Human olfactory capability is dramatically inferior to that of most carnivores. Human reaction times are slower than many insects. The neural hardware for sensory processing in the human brain is not particularly impressive by the standards of the animal kingdom. What is impressive, what appears to be unique, is the capacity for the kind of abstract, recursive, hierarchically structured thought that allows a mind to reason about things that do not exist and have never existed, to construct models of counterfactual situations and reason about their implications, to understand concepts that have no physical referent, to think about thinking. This metacognitive capacity, the ability to represent and reason about the contents of one's own mind and the minds of others, is the foundation of language and theory of mind and scientific reasoning and mathematics and every other distinctively human cognitive capability. A chimpanzee can solve a multi-step problem to obtain a food reward. A chimpanzee cannot reason about what the problem would look like if one of the steps were different, cannot construct a general theory of problem solving from the specific instance, cannot communicate the solution to another chimpanzee with sufficient fidelity that the receiver could solve a novel problem of the same type without further demonstration. The difference between chimpanzee intelligence and human intelligence is not a matter of degree in the way that a faster computer is more capable than a slower one running the same software. It is a difference in kind. A qualitative difference in what kind of representations the brain can construct and what kind of operations it can perform on them. The evolutionary origin of this qualitative difference is not fully understood. The genetic differences between humans and chimpanzees amount to roughly 1 to 2% of the genome, depending on how the comparison is conducted. The neural differences that produce the qualitative cognitive gap between the two species emerge from relatively modest genetic changes that affect brain development in ways that produce the expanded prefrontal cortex and the altered connectivity patterns and the extended developmental timeline that characterize the human brain. Evolution, working through variation and selection on a genetic architecture inherited from a common ancestor shared with chimpanzees approximately 6 million years ago, produced a brain capable of understanding the 13.8 billion year history of the universe from the raw materials of a primate nervous system. The brain that could do this was not designed for this purpose. It was designed, in the sense that natural selection shapes organisms, for the ecological demands of a social primate living in complex social groups, navigating three-dimensional arboreal environments, using tools to extract food from resistant substrates, competing and cooperating with conspecifics whose intentions and capabilities had to be modeled and predicted. The cognitive capabilities required for these ecological demands, particularly the social demands, drove the expansion and elaboration of the prefrontal cortex and the neural circuits supporting theory of mind and language and abstract reasoning. Scientific thinking and mathematical reasoning and philosophical inquiry are byproducts of this elaboration. Capabilities that emerge from the neural machinery built for social navigation and ecological problem solving, and that turned out when the cumulative knowledge transmission enabled by language was added to the equation, to be capable of things far beyond anything the original selective pressures required. The universe did not build a brain capable of understanding the universe. It built a star that produced the heavy elements that became a planet, that produced the conditions for life, that produced the evolutionary pressures that produced a primate brain that, through the accident of its specific architecture and the cumulative knowledge transmission that language made possible, turned out to be capable of understanding the universe. The capability exceeded the design specification by a margin that has no precedent in the history of biological evolution on this planet. And what that brain has done with this unintended capability in the geological eye blink since its emergence is the most concentrated period of knowledge acquisition in the history of life on Earth. In the 70,000 years since the behavioral revolution, and more dramatically in the 12,000 years since agriculture, and more dramatically still in the 400 years since the scientific revolution, the cumulative knowledge structure that human language and writing makes possible has grown at a rate that no previous biological knowledge system has approached. The understanding of the physical universe available to a scientist today is separated from the understanding available to the most sophisticated thinker of 400 years ago by a gulf that makes 400 years of human cultural development look like the most dramatic transformation in the intellectual history of any species that has ever existed on this planet. We know the age of the universe to within a few percent. We know the composition of stars 13 billion light-years away from the spectral signatures of their light. We know the structure of the genome of organisms that went extinct 40,000 years ago from ancient DNA extracted from their bones. We know the temperature of the cosmic microwave background, the faint afterglow of the Big Bang, to 6 decimal places. We know the mass of the electron to 12 significant figures. We know the distance to the moon to within a millimeter from laser-ranging experiments. We know the structure of proteins from the sequences of the genes that encode them. We know the history of continental movement from the paleomagnetic signatures in ancient rocks. We know the timing of ice ages from the isotopic composition of ice cores drilled from the Greenland and Antarctic ice sheets. All of this knowledge exists in a brain that weighs 1.4 kilograms and fits inside a human skull and runs on 20 watts of metabolic power. a brain that evolved for social navigation in primate groups on the African savanna. A brain that was not designed to understand any of this and that understands all of it anyway, because the architecture required for the cognitive demands of social primate life turned out, when elaborated by evolution and augmented by cumulative cultural transmission, to be capable of reconstructing the history of the universe from the evidence it left behind. That is the most astonishing thing that has happened in 13.8 billion years of the universe, operating without awareness of itself. Not the formation of stars, not the emergence of galaxies, not the complex chemistry of planetary formation. The emergence, on one small rocky planet orbiting one ordinary star, of an arrangement of matter capable of understanding the arrangement of matter. And there is one more layer to this story, one more place the chain of improbable events leads. A place that the next segment reaches by inverting everything established so far and revealing that the most remarkable fact about the brain capable of understanding the universe is not what it knows, but what it knows about what it does not know. The boundary of human understanding, where the cumulative knowledge structure currently ends, and what stands beyond that boundary, waiting. Step outside on a clear night, away from city lights if you can manage it, far enough from artificial illumination that the sky reveals itself in its full depth, rather than the washed-out handful of bright stars visible from urban locations. Let your eyes adjust. The process takes roughly 20 minutes as the photoreceptors in your retina shift from the cone-dominated day vision optimized for color and detail to the rod-dominated night vision optimized for sensitivity to faint light. As the adjustment completes, the sky fills progressively with stars, the Milky Way appearing as a diffuse band across the sky, individual stars resolving from the background glow, the full depth of the night becoming apparent in a way that the unadjusted eye cannot access. What you are looking at in this moment is the universe as it existed at various points in the past, each point different depending on the distance of the object you are observing. The moon as it was 1.3 seconds ago, the sun as it was 8 minutes ago, the nearest stars as they were years to decades ago, the stars of the familiar constellations as they were hundreds to thousands of years ago, the Andromeda Galaxy, visible to the naked eye as a faint smudge in the constellation Perseus on a sufficiently dark night, as it was 2.5 million years ago, the faint glow of the Milky Way itself as it was tens of thousands of years ago, the light from stars on the far side of the galaxy having spent 100,000 years crossing the galactic disk to reach your eyes. You are not looking at the night sky. You are looking at a time-lapse archive of the universe assembled from messages sent at different moments across billions of years of cosmic history, all arriving simultaneously at two biological detectors roughly 3 centimeters in diameter, connected to a 1.4 kilogram neural processing system that evolved for reasons entirely unrelated to cosmic observation. Now consider what it means that you can understand this, not merely observe it, understand it. Know that the faint smudge in Perseus is a galaxy containing 1 trillion stars 2.5 million light-years away. Know that the light reaching your eyes tonight left that galaxy when your ancestors were Australopithecines learning to make stone tools on the African savanna. Know that the galaxy is approaching at roughly 110 kilometers per second and will collide with the Milky Way in approximately 4.5 billion years. Know that the collision will not destroy the stars within either galaxy because stars are so widely separated that direct stellar collisions will be extremely rare even when the galaxies interpenetrate. Know that the merged system will eventually settle into an elliptical galaxy whose future astronomers will inhabit a cosmos from which all evidence of the larger universe has been erased by accelerating expansion. You know all of this, not because you figured it out yourself, because a chain of cumulative knowledge transmission running from the first humans who noticed that certain celestial objects moved relative to the background stars through Copernicus and Galileo and Newton and Einstein and Hubble, and every astronomer and physicist and cosmologist who added their increment to the cumulative structure, reached you in the form of the understanding you carry right now. The chain held for 70,000 years, and it delivered to you in the span of a human lifetime of learning. a picture of the universe that no individual could have constructed from scratch, and that no previous generation in human history possessed in this form. This is the first remarkable fact that becomes visible when you step outside and look up with the understanding that the preceding 6 segments of this video have assembled. You are standing on a rock that was a magma ocean 4.5 billion years ago, looking at a galaxy that contains 1 trillion stars and is moving toward you at 110 kilometers per second, and you understand what you are seeing. The universe has produced in you an observer capable of comprehending the universe. That is not an ordinary outcome of 13.8 billion years of physical processes operating without awareness of themselves. It may be the most extraordinary outcome those processes have ever achieved. But there is a second remarkable fact that becomes visible when you look up on that clear night. One that is in some ways more astonishing than the first because it is so thoroughly invisible until you know what to look for. And once you see it, it changes what the night sky means in a way that cannot be reversed. Every point of light you can see with the naked eye on that clear night, every star in every constellation, every member of the Milky Way's stellar population visible from your location is inside a sphere approximately 2,500 light-years in radius centered on Earth. Everything the human eye can see in the night sky is inside a tiny bubble, less than 3% of the diameter of the Milky Way, a small patch of one spiral arm of one galaxy among 2 trillion galaxies in the observable universe. The visible night sky, which feels so vast and overwhelming in its darkness and its multiplicity of stars, is a close-up view of a tiny neighborhood, the nearest fraction of the nearest fraction of what exists. And beyond the naked eye stars, beyond the depth that the human eye can resolve, there is more, vastly more, incomparably more. The Hubble Space Telescope pointed at a patch of sky so dark that it appeared completely empty to ground-based instruments, collected light for over 10 days, and resolved approximately 10,000 galaxies in a region of sky smaller than the area covered by a grain of sand held at arm's length. 10,000 galaxies, each one containing tens to hundreds of billions of stars. In a patch of sky so small that you would not notice it with your naked eye, and that appeared to be empty darkness to every telescope that had looked at it before Hubble. And that was one patch. The sky contains approximately 12.7 million such patches, at the angular size of the Hubble Deep Field. If every patch contained a similar density of galaxies, the observable universe contains something in the range of 2 trillion galaxies in total. 2 trillion galaxies, each containing hundreds of billions of stars, each star a nuclear furnace, many with planetary systems. Some of those planets in the right temperature range for liquid water. Some of those planets with the right atmospheric chemistry. Some of those planets, possibly, with the right biological history. Possibly with organisms. Possibly with intelligent organisms. Possibly with intelligent organisms who also stepped outside on a clear night, on their version of a rocky planet orbiting their version of an ordinary star, and looked up at their version of a night sky and wondered. We do not know. This is the honest answer and the only defensible answer. The search for extraterrestrial intelligence has been ongoing in various forms for more than 60 years. The specific search for biosignatures, the chemical signatures of life in the atmospheres of exoplanets, is now being conducted by the James Webb Space Telescope with unprecedented sensitivity. No confirmed detection of life elsewhere has been made. The sky is silent in the electromagnetic spectrum. The search continues and is still in its early stages relative to the scope of what needs to be searched. But the silence is not the most important thing about the situation. The most important thing is the fact that the question is being asked at all, that somewhere in the universe, in a specific location on the surface of a specific rocky planet orbiting a specific star in an outer spiral arm of a specific galaxy, arrangements of matter have reached a level of complexity sufficient to wonder whether other arrangements of matter have reached similar complexity elsewhere. The universe, which operated for 13.8 billion years as a purely physical process with no observer and no question, has produced at least one location where observation occurs and questions are asked. The minimum that can be said with certainty is one. You are the evidence of the minimum. What the maximum might be is unknown. And the unknown is not a failure of science or a gap in the chain of cumulative knowledge transmission that will eventually be filled. It is the honest current state of the evidence. The universe is vast enough and old enough that the probability of other observers existing somewhere within it is not negligible by any reasonable calculation. The probability of any observer in the history of the universe ever communicating with any other observer is constrained by the speed of light and the distances that separate the locations where observers might have emerged, and the timescales on which civilizations persist relative to the communication delays those distances impose. The silence may not mean emptiness, it may mean isolation. The universe may contain observers in abundance who are asking the same question from behind the same wall of light years that prevents any answer from arriving in any time frame relevant to the civilization asking it. The Fermi paradox, the apparent contradiction between the probability of other intelligent life and the absence of detected evidence for it, may have its resolution here, in the geometry of a universe where the speed of causality is insufficient for the distances between the locations where causality has produced observers capable of wondering about each other, and this possibility that the universe may contain observers in isolation from each other, each one asking the same question from behind walls of light years, changes what your moment of standing outside on a clear night means. You are not one observer in a universe full of connected observers sharing information and experience across a cosmic community. You are one observer or part of one civilization of observers, separated from any potential others by distances and communication delays that make meaningful connection effectively impossible within the lifespan of any civilization. Whatever other observers exist, if they exist, they are experiencing their own version of isolation, their own version of standing under a vast sky and wondering whether the universe contains anyone else wondering. The isolation is not emptiness. It is the condition of existence for any observer anywhere in a universe structured the way this one is. And recognizing it changes the question from whether we are alone to what it means to be observers in a universe that may contain observers who will never know about each other. Now return to Earth. Return to the chain of events assembled across this video. The magma ocean and the self-replicating chemistry and the oxygen catastrophe and the snowball Earth and the asteroid that cleared the way for mammals and the language that turned individual intelligence into cumulative civilization and the brain that evolved for social navigation and turned out to be capable of understanding the universe it found itself in. Every link in that chain was improbable. Not improbable in the sense of impossible, because you are the evidence that it happened, but improbable in the sense that at every step, the outcome was not guaranteed. The alternative outcomes were more numerous than the actual outcome. The specific result that occurred was the one that the subsequent chain required and that no prior process was directing toward. The magma ocean was not trying to produce you. The oxygen catastrophe was not designed to make aerobic respiration possible. The Chicxulub asteroid was not aimed at clearing the way for mammalian diversification. The primate lineage was not selected for abstract reasoning. The behavioral revolution was not engineered to produce cumulative knowledge transmission. Every step that was required for you to exist happened without any process directing it toward that outcome. The universe did not set out to produce an observer. It produced an observer anyway. Through a sequence of physical and chemical and biological and cognitive accidents that accumulated over 4.5 billion years into the specific configuration that is sitting wherever you are sitting right now, reading these words. And this specific configuration, this specific arrangement of stardust that the universe assembled through accident and catastrophe and selection across 4.5 billion years, is doing something that no prior arrangement in the universe's history has been confirmed to have done. It is understanding what it is. It is reconstructing, from the evidence embedded in ancient rocks and fossil records and stellar spectra, and molecular sequences, and the cosmic microwave background, the history of the process that produced it. It is turning the physical universe's 13.8 billion year history into a story that a 1.4 kilogram neural processing system can comprehend. The most astonishing fact of all is not the universe's size or its age or its complexity. It is that any of it is known, that the universe, which had no observer and no question for its first several billion years, eventually produced an arrangement of matter capable of asking how it all began, and following that question through the fossil record and the chemistry of ancient rocks, and the light from distant stars to answers of genuine precision. The astonishment is not the answer. It is the fact of the asking. You are 4.5 billion years of planetary history. You are 4 billion years of biological evolution. You are 70,000 years of cumulative cultural transmission. You are the specific sequence of catastrophes that made complex life possible, and the specific accidents that produced a lineage capable of language, and the specific elaboration of a primate brain that produced abstract reasoning. You are the stardust of stars that died before the sun formed, assembled through every improbable step of Earth's history into the one configuration that has ever, in the confirmed history of this universe, looked up at the night sky and understood what it was seeing. That is the most remarkable thing the universe has produced in 13.8 billion years, and it is happening in you, right now, in the quiet of wherever you are, at the end of a video that followed the chain from the magma ocean to this moment. In the brief window of cosmic visibility that exists before accelerating expansion, closes the observable universe into a smaller and smaller cell and erases the evidence of its own history from the sky. The window is open. The evidence is still visible. The chain of cumulative knowledge transmission that brought this understanding to you is still intact. And the question of what you do with that understanding, within the specific and finite time that the physics of this universe permits, is the only question the physics leaves open. Nocturnal space exists to follow questions like the ones in this video past the comfortable stopping points and through to wherever the evidence actually leads. Every video on this channel is another link in the chain of cumulative transmission that began 70,000 years ago, and that reaches you here, or as in this specific moment of the universe's history, while the window is still open. Subscribe now. Turn on notifications. Share this video with anyone who has ever looked up at the night sky and felt the scale of what is out there without quite being able to articulate what that scale means for the small, improbable, extraordinarily fortunate arrangement of matter looking up at it. Leave the word astonishing in the comments if this reached you tonight. Just that word. Because you are. By every measure the universe has provided. By every standard the evidence supports. By every calculation the chain of events that produced you makes possible. You are the most astonishing thing in the known universe, and you are here to know it. For now, that is enough.